we're going to start chapter 19 about electrochemistry. And what is electrochemistry? As the name says, electrons and chemistry. So it's basically effective electron transfer on a chemical reaction, or let's say the relation between electron transfer and chemical reactions. In this regard, we are going to refer to two of the different types of cells that we have, and we will work with them either at home or in the industry. The first one is Voltaic or Galvanic cells that we will study in more details. These type of cells, they use a spontaneous reaction to generate electric current, just like the batteries, just like AA or AAA batteries. These are the types of Voltaic or galvanic cells. You use the spontaneous reaction between the two anode and cathode. You see the positive and negative charge on the batteries. That shows the two parts that we mentioned later on. And we generate an electric current until there would be no more material left, and that's when we say the battery dies. The second type of cell, which works the opposite of voltaic or galvanic cells, is called electrolytic cells. In the electrolytic cells, you give an electric current to drive a non-spontaneous reaction, like what happens in electroplating. I'm sure you all have heard about electroplating. This is what you will do for your experiment next week. For the electrochemistry experiment, you will use you work on an electrolytic cell. One thing before we start this chapter is that you remember for acids and bases and for equilibrium, you use the H3O, hydronium ion. So instead of hydronium ion, we use a simpler notation, which is just hydrogen ion. So instead of hydronium ion, they are the same, but instead of hydronium ion, we use its simpler form, which is called proton. So we are going to start this chapter, and before anything else, let's have a quick refreshment on what we had in Chem 1. Remember oxidation and reduction. Oxidation, when an atom loses electrons, so electron loss. And reduction happens when an atom gains electrons, so it's electron gain. And we had some oxidation rules, oxidation numbers, and so on. Let's work on it with an example. Fe2 plus NO3 negative gives F3 plus NO. Obviously we haven't shown the anions, right? Just Fe2 and Fe3. So let's determine the oxidation numbers. Oxidation number, if you forgot, you go back to I guess, if I'm not wrong, it was chapter 4. You will go back to chapter 4 and review oxidation numbers. I'm not going to go over each of them one by one now. You know that oxidation number of monoatomic ions is the same as their charge, because what is oxidation number is nothing but the charge that is transferred. The oxidation number of Fe is positive 3 here. Again, it's a monatomic ion. For oxidation number of nitrogen, you remember that you use a small equation to find the oxidation number of nitrogen. We would say there is one nitrogen in the formula with an unknown oxidation number or unknown charge. Said oxidation number and charge are the same. Plus 3 oxygens. And again, from oxidation number rules, oxidation number of oxygen most of the times is -2. So it's -2, and it should be equal to the charge. If there is a charge, it should be equal to that charge. So this negative is this. All right. So when you find it, the oxidation number of nitrogen is going to be +5. The same thing here. Oxidation number of nitrogen, 1 times nitrogen plus oxygen. There is just 1 oxygen, and oxidation number of oxygen most of the times is -2. There is no charge on the molecule, so it's equal to 0. So oxidation number of nitrogen here is going to be +2. So that's how we determine the oxidation number. Why did we have a review on oxidation numbers? Because we're going to start balancing the oxidation reduction equations. Let's start with the same reaction. We're going to the same reaction using oxidation reduction method. You had it before in Chem 1, again chapter 4, but I don't think this marker is good anymore. Dismissed. +2 plus, we want to balance it. So far we just found the oxidation numbers. Right? We said this is +2, this is +3, this is +5, and this is +2. So when the oxidation number increases, the oxidation has happened. We just showed it OX. When the oxidation number decreases, reduction happens. So we need to split this whole reaction to 2 half reactions. So far you had it in Chem 1, Fe +2, or let's say oxidation half reaction. Fe +2 changes to Fe +3. We needed to do the mass balance and the charge balance. First, the number of atoms, 1 iron, but the charge, we have a +3 here, but we have a +2 here. How to do the charge balance? We always add electron to more positive side. More positive side is this side. How many electrons do we need to make the balance between 3 and 2? 1 electron. That's for oxidation half reaction. So let's take care of reduction half reaction. All right. For reduction half reaction, we said nitrogen has been reduced. So this is the reduction half reaction. Now, we are going to, the question says, balance it in acidic solution. So, how to balance it in an acidic solution? You see the number of nitrogens are the same, still no charges involved, but you need to balance the number of oxygens. In order to balance the number of oxygens, you need to add water molecules because water contains oxygen. Now you have 3 oxygens here and 1 oxygen here. How many more oxygens do you need? 2 more. And in 1 water molecule, you have 1 oxygen, so you need 2 water molecules, right? In liquid form. Then at the same time that you're adding 2 oxygen molecules, now you have 1 oxygen plus 2 oxygens, 3 and 3. Oxygens are balanced, but what did you just create? Hydrogens, right? 2 times 2 is 4 hydrogens. How do you balance the number of hydrogens? By adding 4 hydrogens here, by adding 4 hydrogen ions. And we said instead of H3O hydronium ion, we use its simpler form. Alright? And this is in aqueous form also. Then we just created a charge. Positive 4 because 4 times positive 4 and 0. We always add electrons to more positive side. And I'm sorry, NO3 has a negative. So positive 4 minus 1 is positive 3. And on the other side you have 0. So how many electrons do you need to add? 3 electrons to more positive side. 3 electrons. So this is reduction. Alright, so seems like both of our half reactions are mass balanced and charge balanced. Now, because we need to write this overall equation, you need to add these two, and the equation is composed of oxidation half reaction and reduction half reaction. So you need to add these two, but we need to be able to cancel we should be able to cancel the number of electrons. We have 3 here, but 1 there. So go ahead and multiply the top reaction, both sides, by 3. So now, when you add them up, you can cancel 3 electrons and 3 electrons. So what is left here is 3 iron, positive 2, plus NO3, plus 4 hydrogen ions. They're all aqueous. If you write the physical states, that makes it more complete. And on the other side, you have 3 Fe3 plus NO plus 2 H2O. Again, they are aqueous, and water is liquid. So now you have balanced this equation, and the question was asking in the acidic solution. So you are showing the acidic solution because hydrogen ion is the symbol for acidic solution. Okay, and feel free to balance the atoms again. You have 3 Fe, 3 Fe, 1 N, 1 N. 3 oxygens, 2 and 1, 3 oxygens, 4 hydrogens, and 2 times 2, 4 hydrogens. The charges is 3 times 2, positive 6, plus positive 4, positive 10, minus 1, positive 9, and here 3 times positive 3, positive 9. So everything is balanced. The next question on slide number 18 is another example of oxidation reduction reactions and balancing them. So it says dichromate ion in acidic solution is an oxidizing agent. When it reacts with zinc, the metal is oxidized to zinc 2 and nitrate is reduced. Assume that dichromate ion is reduced to chromium 3. Write the balanced ionic equation for this reaction using the half reaction method. So dichromate is Cr2O7 negative 2. It says in the acidic solution, it's going to change to chromium 3. And what else is saying? The metal is oxidized to zinc 2. Metal is solid, zinc 2. Okay, the rest of them are aqueous. Why do I emphasize on these physical states? Because you will see that the oxidation number for metal is 0, and for an ion is positive 2. So this has been oxidized because oxidation number increased, and the oxidation number of chromium, you will find it again, 2 chromium from that equation I told you, plus 7 times negative 2 for oxygens. What is the total? Must be equal to negative 2. So when you find it, the oxidation number for chromium is going to be positive 6. So chromium went from positive 6 to positive 3. It's being reduced. So chromium forms the oxidation half reaction, and zinc forms the oxidation. The chromium forms the reduction, and zinc forms the oxidation. So let me just get rid of these. This is the oxidation, and this is the reduction half reaction. Alright, so for zinc, you just need to add the more positive side to electron, because 1 zinc and 1 zinc, nothing else, just 2 electrons. For chromium, your mass is now balanced, 2 chromium and 2 chromium here. So let's just clean it a little bit. Alright, so 2 chromium, 2 chromium. How many oxygens do you have? 7. How did we balance the oxygens? By adding water molecules. 7 water molecules are needed. So at the same time, what did you generate? 7 times 2, 14 hydrogens that you will add here, plus 14 hydrogens. And it's time to balance the charge. Let's see. Positive 14 minus 2 is positive 12. And here you have 2 times 3, positive 6. So how do you change positive 2 to positive 6? You will need 6 electrons on the more positive side. Now, again, we are done with the 2 half reactions, but you are supposed to add them to each other. But before that, you need to make sure the number of electrons are the same, which is not here. So you multiply the bottom one by 3 to make them the same. 3 zinc solid gives 3 aqua zinc plus 6 electrons. So 6 and 6 are canceled. Then you will have 14 hydrogens plus Cr2O7 negative 2 plus 3 zinc from the second equation in the solid form, and nothing else left from the left side. On the right side you have 2 chromium ions, positive 3 plus 3 zinc ions plus 7H2O. Go ahead and check. Everything must be balanced, and you see this is in, again, acidic solution. Now, what if we want to balance our equation in a basic solution? So far, all of them were in acidic solution. So, the only difference is that you balance the equation the same exact way as what you did for acidic solution. The change is at the end when you turn it to a basic solution. Let's work on another example and balance it in a basic solution. Means basic solution means we have added OH, right? So here's the equation. PbOH3 with a negative charge, it says lead 2 ion yields the plomic ion in basic solution. This is plomic ion. In turn, this ion is oxidized in basic hypochlorite solution. This is ClO. To lead 4 oxide. This is lead 2,4 oxide. Lead 4 oxide, sorry, not 2. And chloride will be released. So let's balance this equation using half reaction method in basic solution. So let's find out the the oxidation numbers first. We don't know the oxidation number here, but we know it said lead 4. So let's see what is the oxidation number of lead here. 1 Pb. And what's the oxidation number of OH? You can say OH or just 1 by 1. 3 times, it's better to be 1 by 1. 3 times -2 for oxygen plus 3 times +1 for hydrogen. How do I know these? All from oxidation rules you get from chapter 4. Please study. Is equal to -1 because we have it here. And then here Pb ends up having an oxidation number of +2. So +2 to +4 oxidation half reaction is Pb. Can I say +2 to +4? Let's write everything because we need them. Acidic and basic solution. Okay. And to make sure that chlorine has been reduced, the chlorine, when you find it, is -2. 1 times chlorine plus -2. 1 times -2 equals to -1. So oxidation number of chlorine here is +1, and here is -1. So reduce from +1 to -1. So reduction half reaction is ClO to CCl. Okay, now it's time to start balancing these equations. Pb is the same. 3 oxygens, 2 oxygens. How do we add more oxygens? By adding more water. And how many more do you need? 2 only. And now, how many hydrogens? How many hydrogens do you have? 3, but you have only 2 of them there. So you will add 1 more hydrogen ion. You have a -1, you have a +1. How do you balance the number of electrons? You always add electrons to more positive side. Why? Because electrons have a negative charge. So you add 2 electrons to this side. -2 plus 1 is -1. For the reduction half reaction, you will have to add 1 water to balance the oxygen because the chlorine atoms are balanced. You have 2 hydrogens here, so you need to add 2 hydrogens to this side, and you have +2 -1, +1, and here -1, so you need a 2 electron here. Luckily the electrons are the same, so go ahead and add them to each other. Pb OH 3 negative plus ClO negative plus 2H. You go to the other side, PbO2 plus Cl plus how many water molecules? 2 water molecules and 1 hydrogen ion. So you have 1 hydrogen ion on the right side, 2 hydrogen ions on the left side. So go ahead and subtract them from each other. You don't have any on the right side. So the question says you are supposed to balance it in a basic solution because it said it's mentioned in the basic solution. Means that in the final equation you need to see that basic factor, which is OH. But do you see it so far? No. Go ahead and add enough OH ions. How many OH ions do you need to convert to the basic solution? You add 1 OH to each side, the same number of hydrogen ions to each side, right? Now, H and OH together form what? I'm sure you will say H2O. You have 1 H2O here now, 2 here, right? So go ahead and rewrite Pb OH 3 negative plus ClO. You don't have water here anymore. And on the other side you have PbO2 plus chloride plus 1 water and plus OH negative, right? It shows the basic solution. So the difference between balancing in acidic and basic is that balancing in both of the acidic or basic is the same. The only difference is that if you need to balance in the basic solution, you need to add OH after you get the final equation. How many OH ions? The same as the hydrogen ions. If you have 2H here, you will have 2 OH, then you would have 2 H2O. But now you have 1, you just add 1. If you had 3, you should have added 3. The same number of hydrogen ions. So H and OH on one side will form H2O. But if you have any other H2O on the other side, you will cancel them from each other. And then on the other side, you have OH left. So this is how you balance the equations in 2 different types of solutions. So we're talking about electrochemical cells, that these reactions happen in them all the time, oxidation and reductions. The electrochemical cells are the systems that have 2 electrodes and dipped into the liquid which is called electrolyte. I'm sure you all know a little bit about cells from school. So each electrochemical cell has these components. First, electrodes. Second, electrolyte. Electrolyte is an ionic compound which is going to be ionized 100%, right? An electrolyte is a compound that is ionized 100%, and we also have a salt bridge. So these are the main parts of each electrochemical cell, and we worked on Voltaic or Galvanic Cell and also Electrolytic Cell. Our focus is on Voltaic Cell, and just like the reactions that we had, oxidation half reaction and reduction half reaction, we have the same thing in the cells also. So if you want to show it, let's say very simple example is, let's say you have 2 beakers. In one of them oxidation happens, in one of them reduction happens, and let's say in one of them zinc changes to zinc ion and 2 electrons are released. On the other side, copper ion is ready to grab those 2 electrons. So if you have a zinc plate and a solution of zinc ions, then you have another plate here, a copper plate and a solution of copper ion. Then these 2 will be connected towards a salt bridge. Salt bridge always has an ionic compound in it, like KCl, to make the exchange of, passing the ions easier. But the solutions won't transfer, but the salt bridge makes a circuit kind of. And electrons go from through the wires from where the electrons have been released towards where the electrons are needed. So this is a very simple electrochemical cell. We have a galvanic cell, let's say, So again, one more time, salt bridge is a tube of electrolyte, normally in the form of a gel, which connects the two half cells of the voltaic cell. It allows the flow of ions, prevents mixing of different solutions, direct mixing. So basically, the electrons should always flow. Now, it's important to label the electrode in which the oxidation happens is called anode. Anode, oxidation happens. And the electrode in which the reduction happens is called cathode. It's called cathode. So electrons flow from anode to cathode, because in anode oxidation happens, so electrons flow from anode to cathode, not through the solutions, through the external circuit. Okay, and if you always I'm sure most of you have done it at school when you put the light bulb in the solution, through the wire, and you connected it to anode and cathode, and after a while you saw the light bulb starts lighting. Alright, so since I don't want this video to be too long, I want you to work on these basic concepts. In the next video, we will start with the notation for the voltaic cell.